Example 4.9 from the book Applied Thermodynamics, McConaughey and Stop. Here is the statement: 0.05 kg of carbon dioxide, molar mass 44 kg per kilomole, is compressed from 1 bar 15 centigrade until the pressure is 8.3 bar and the volume is then 0.004 meter cube. Calculate the change of entropy. Take Cp for carbon dioxide is 0.88 kilojoule per kg and assume carbon dioxide to be a perfect gas. So the mass that is given of the carbon dioxide, that is 0.05 kg, and the molar mass that is given, that is 44 kg per kilomole, compressed from 1 bar. The pressure P1 that is given 1 bar, and when compression is taken place, and the initial temperature that is also given, that is 15 centigrade. If you convert that into Kelvin, it will be T1, that is 288 Kelvin. Just add 15 with 273, you will get the 288 K. Next is the P2 after compression. The P2 value that is given is 8.3 bar. You can also write its value is 8.3 multiplied with 10 to the power 5 Newton per meter square. Let me draw a stage diagram for this process. This is T, this is S, this is low pressure line, this is high pressure line. So compression is taken place, so the process will follow from process 1 to 2. The entropy here is S1, the entropy here is, this is S2. The temperature, final temperature is unknown, T2, and the initial temperature that is given, that is T1. If I further extend this point 2, it will intersect with this pressure P1 line, that is 1 bar. This is pressure P2 line, that is 8.3 bar. So this extended line that intersect with the pressure P1 at A and its corresponding entropy is SA. So with the help of this extended line, that we say the process 2 to A, and from process A to 1 we will conclude and calculate that this change in entropy. So let's come to the solution. First of all, we need to find the gas constant for carbon dioxide, that it will be equal to universal gas constant to its molar mass. So the universal gas constant is 8.314 kilojoule per kg divided by molar mass, that is 44. So you will get the gas constant, that is 0.189 kilojoule per kg K. You can also write it at like this: 0.189 10 to the power 3 joule per kg K. Whenever you are using the formula, you will use the pressure value 10 to the power 5 and 10 to the power 3 values. Okay, so here it is decided that the carbon dioxide is perfect gas. So we will use the perfect gas law, that is equal to P2 V2, that is equal to MR T2. So what is the P2 value? That is we need to simplify it for the T2. So the T2 that is equal to P2 V2 divided by MR. And what is P2? That is 8.3 multiplied 10 to the power 5 multiplied by volume that is given, the final volume, that is V2, and here it is value, that is 0.004 divided by mass that is 0.05 multiply with R, that is 0.189 multiply with 10 to the power 3. After simplification you will get that value of T2, that is 351 almost Kelvin. Okay, next we need to determine the change in entropy SA minus S2, SA minus S2, that is taken place at a constant temperature. So that will be equal to R ln, that is equal to P2 divided by PA, and the PA is equal to P1, and that is equal to 1 bar. Thus whatever the points lies on this, what types of point that lies on this line, that will be equal to 1 bar, remember. So the PA and P1 value is equal to 1 bar. So after putting the value, the change in entropy SA minus S2 is equal to R, that is constant, that is 0.28, sorry, that is 0.189, we have calculated that, into ln, what is P2, that is 8.3 divided by PA1. So after simplification you will get that SA minus S2, that is equal to 0.4 kilojoule per kg. Let's say this is equation 1. So next we need to find the, if you look at here, the entropy that follow the line from A to 1, that will, the change in entropy will occur is SA minus S1 is at a constant pressure line. So in this case the change in entropy will be equal to SA minus S1, that is equal to Cp ln the higher temperature T2 divided by T1. So this change in temperature, change in entropy SA minus S1, what is Cp value, that is given here, it is the Cp value for carbon dioxide is 0.88. So that is 0.88 ln T2. T2 is the higher temperature, that is 351, divided by the lower temperature, that is 288. So after simplifications you will see that the change in entropy SA minus S2, that will be equal to 0.174 kilojoule per kg, and this say this equation 2. Now subtract equation 2 from 1, so I can write that SA minus S2 minus SA minus S2 will be equal to 0.4 minus 0.174. So this A will be cancelled out with this, and remember this is 1 SA minus S1, because here we are performing for SA minus S1, that was all mistakes, sorry. So here it will also be S1. So this S1 minus S2, that is equal to 226 kilojoule per kg. And this change in entropy is for 1 kg mass. If the mass is 0.0113 kilojoule per Kelvin. Now in unit the kg term is finished because we multiplied it with the mass. So the kg term will be cancelled out with kg, and the unit is now, and this obviously entropy unit is kilojoule per Kelvin.